All right, well, this is the Inequality Notes. I have never talked to a computer screen before, so this will be interesting to see. So these are the notes that I would be giving you today about inequalities. Inequalities, and you should be writing all this in your notebook. I'm sorry I'm not here on Thursday or Friday. If you have any questions, email me. But inequalities are used for problems that do not have an equal sign. The first one is going to be less than. It's pointing to the left, greater than, and then below those there are less than or equal to. If I could get a pointer or something. Let's see. And then below that is greater than or equal to. I don't know. I'm not sure how to point to what I want, but I'll just use this. One of the things that I think about is like an equal sign has like the two lines, and then so like these have that, like the bottom of it looks like an equal sign, so it can be equal to whatever number is to the left or to the right of it. So feel free to pause this and put this in your notes. I'm going to move on to the next slide. All right, common inequality phrases. So at most. What do you think at most could mean? Which of those inequalities? Well, at most means it could be that number at the most or less than. Be above. So sometimes with like be above, you'll see be above. What does that mean? Well, that means it cannot equal that number, but it could be greater than it. At least. Well, this one's confusing because when people see least, they always think like, oh, it's got to be, small, so a small number or smaller than. No, at least means like, for example, I have at least 20 bucks in my pocket. I could have 20, or I could have like 100. I said I had at least 20. I have 100. So at least means it could be that number, or it can be over it. Less than. Less than means it cannot be that number. It has to be smaller. Like, it needs to be smaller, not equal to it. Like, I have less than $20 in my pocket. Well, I can't even have 20. I could have $19.99, but I can't have 20. I know when I was a student, I would always have trouble of like, at least or at most. Those were the ones that gave me trouble. Yeah, I would write these down also. You'll see at least, or at least hear about it throughout the unit. All right, and then how do we graph these? So on a number line, we can graph inequalities. We use a open circle when it does not include that that number. So for example, when I said like I have, so let's go back to this one. When I have less than, I have less than $20. I would use this one, the open circle. I have less than 20. I do not have 20. I have less than 20. You use the closed circle to include the point. So I have at least 20. So that would be at least $20, and I would shade in 20, and then shade to the right, increasing. All right, so open circle, closed circle. All right, so let's practice this. How would I read this? Well, you would read this as x is greater than 1. All right, so is it equal to 1? No. So I'm going to want to use an open circle. Okay. And then greater than 1. And I'm going to want to shade to the right. So I'm going to... Let's see if this looks good. Oh yeah, look at that. That came out nice. All right, shade to the right. So could give me one value that satisfies this. 2. What about 1.5? What about 1.1? Yes, that would. Some people graph it and they have it hovering above the number line like this, I mean, it's not wrong. I just don't like it. I prefer if you graphed on the actual number line and shaded which way you're going. That's what you'll see most of the time. Some people do elevate it, but I'm not one of those people. All right, and anything else? I think we're good. All right, what about this one? How would you read this? Well, this one would be read as x is less than or equal to 1. So this was going to be a closed circle. I'll just use the one I have. So I'm going to go to 1. And it's close because it could equal 1. So I'm gonna shade that in. And then I'm going to shade to which direction? Command, let's see. Alright, so we're going to shade to the left. Some of you might have picked up on, hey, when the arrow is pointing to the right in the inequality, oh, it looks like it's always going right. If the arrow is pointing to the left in the inequality, it looks like the shading is always going to go left. That is true only when your variable is on the left-hand side. Is it always going to be on the left-hand side? No. So if it's on the right, you could always switch it to the left and then use this little rule that you figured out. All right, let's keep going. All right. For example, look at this. X is on the right-hand side, so I'm going to flip it. I'm going to flip it. I'm going to say, what's equal to this? X is, well, greater than 6. These mean the same. These are the same. They have the same meaning. All right. Now, which one do you want to graph? Well, I'm going to graph this one since it's the rule we were just talking about. X is greater than 6. So open circle, cannot equal 6, going to the right. All right. Would you take a moment, pause the video, and try to graph this one on your own and see what you come up with? So pause it and then play it, and I will show you what it's supposed to look like, and you can check your answer. All right, hopefully you paused it. The first thing you want to do is create the number. So I'm going to put -2, and then you want to go to the right. So we're going a little bit bigger. Then you should have had -1, 0. Then we go lesser, -3, and then -4. All right, so I'm going to line these up so they look nice. All right, so we're going to get a closed circle. On -2. Shaded to the right, it looks like. When you shade, you could use a highlighter, but it just needs to be bolder than the other one. All right, we got a couple more slides here. All right, now we're solving equations. You're going to solve these like one-step equations. I'm running a little late to a meeting, so I'm going to be speeding it up. Feel free to pause it. Email me if you have any questions. To solve this equation, you're going to subtract 1 on both sides, or subtract 5 on both sides. And then you're going to clean it up. Oh, that is not a good. Let's see. This looks better. All right, we're cleaning it up. All right, so what are we left with? We're left with x is all right, x is less than or equal to, well, now we're going to have -14 on this side. So if we were going to graph this, we would want -14 You only need 2 or 3 numbers on each side. So then this would be negative 13. This would be negative 15 on this side. Alright, so then it would be closed circle going to the left. Alright, going to the left. Alright, let's move on. This one is going to be, alright, so it's 11y is less than negative 132. On this one, we're going to want to divide both sides. Alright, still got the arrow. I'm going to get rid of that. Alright, just divide both sides by 11. Alright, so what is 132 divided by 11? Well, is it going to be positive or negative? It's going to be negative. It's going to equal 12. So we're going to say y is less than negative 12. And we are going to put a couple numbers on here. No need to go all the way to 10 or anything like that. You just have to have, I usually put the main one that we're centering on in the middle. So negative 12, negative 11, negative 13, and then you would have negative 10 and negative 14. Alright, this is going to be a open circle going to the left. Alright, so that's what that looks like. And looks like the last example. Alright, so it's called a compound inequality. So you got to graph each of these separately. So the first thing you want to do is graph this. F is greater than or equal to 1. So I'm going to come over here. Well, let's put some numbers up. Let's go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Alright. Alright. This is kind of like the roller coaster example where you have to be above a certain height, but below, like you got to be above 3 foot 5 inches, but you have to be below 7 feet. So sometimes inequality could have 2 requirements. So if I'm looking at the first one, f is less than or equal to 1, well, that's a closed circle on 1. Alright, let's make it closed. Shaded to the right. Alright, now you look at the left one. F is less than negative 3. So this would be an open circle on negative 3. And this one's going to be shaded to the left. Alright. So everything in between does not satisfy the inequality. Everything shaded does. Sometimes, I mean, I'll show you an example probably next week, but sometimes a compound inequality could be shaded between these areas. Alright, well, that's it for notes. Have a good weekend.